Alright, so hi guys. So in this video, what I want to do is I want to go over this kind of problem. So give me a second, actually, hold on guys, I'm sorry. Alright, sorry about that guys. So, I'm sorry, hold on. Here we go. So in this problem, we want to go ahead and, so here it says find the polynomial function of degree 4 in standard form whose, given the zeros and leading coefficient. So the zeros here, guys, are 1 plus 3i, x equals negative 1, x equals 2, and then a equals negative 1. So I just want to state that this part here would be my leading coefficient. So just to not get confused, this is my leading coefficient. Okay. And I want to go over this, guys, because it is something that we need to understand in algebra when it comes to actually doing complex conjugate theorem, as well as, I think, fundamental theorem of algebra. I can't quite remember, but it has to do with polynomials. So when you study polynomial functions, you have to know how to do this. So here, let's just kind of go over some theorems. So there's the zero factor theorem. And I guess that's a good name for it. I don't know exactly what it's called. Because I think they call it different names, but this just means that if x equals negative a, let's say negative a, right, is 0, then if we add a on both sides, right, we would say that x plus a is a factor of f of x. Let me think, hold on guys, is a 0 of a polynomial f of x. Then x plus a is a 0 of f of x. I'm sorry, is a factor of f of x, excuse me. So we want to understand that, guys. So just like if I say, I don't know, if I say, for example, x plus 2 times x plus 1 equals 0, I know that this is x equals negative 2, x equals negative 1. So these are my zeros. And if this is true, then these two things right here are considered the factors, okay? Usually we call them linear factors. So is a linear factor of f of x. Usually we call those linear factors. Same goes for the other ones. So another one is the following. So let me just copy and paste this right quick and kind of fix it, guys. Give me a second. Okay, so if x so I'm sorry, I forgot to fix it. Here, let's say x equals a is a 0 of f of x. Then x minus a is a factor of f of x. So, give me a second, guys. Okay, so here we want to understand these two things, guys. So to do this, and also there's one more thing I want to go over. There's the complex conjugate theorem. and I'm sure these are, if you're in college or if you're in high school, if you use a textbook, it should be in your textbook. They usually teach it to you in your class, but we'll still go over it. So basically, if x equals a plus bi, right? Let's say bi is a zero of f of x, where a and b are real numbers. A and b are real numbers. Then x equals a minus bi. Minus bi must also be a zero. Of f of x. And usually we would say a complex zero, right? So we want to make sure, guys, that we understand that stuff, okay? And then I also want to mention the idea of the square root of -1 is plus or minus I. And actually, no, is equal to I. So what I mean is, if this is true, if I equals square root of -1, then I squared equals -1. That is if you square both sides, right? Then I squared equals -1. So this is just something that we need to understand. Rules of complex imaginary number. I. Okay, guys, actually, and you know what? I think I'm going to end it here because these are just definitions, guys. I want to make sure we understand this. I will go over the example in the next video. I just don't want to make it really, really long. So, we will go over this actual example in the next video. I will post when I do post this video. I will post a link to the next video, and then for the next video after this, I'll post a link to this video. So I'm going to end it here, guys. I know I said I was going to do this problem, but I want to make sure that we understand these theorems first, and then we will go over the video. I will make another video on the actual problem. So I do hope this helps, guys. With that being said, thank y'all so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.